Morning, Year 12. Sorry I'm not there today because I'm looking after my daughter, but I wanted to put a video together just to teach you how to do a new topic that I'd like you to practice during period 2 today. So this is back in mechanics, like I said I was going to be, and it's variable acceleration. So this will not involve SUVAT at all. SUVAT basically works when acceleration is constant. But if it's changing, then we need to use integration and differentiation to find out positions and also find out velocities. So if it is changing, we need to use integration. Or differentiation. Now I'm just going to focus on the differentiation bit today. So if I get an equation, so they could tell me that S is equal to 5t squared minus 3t plus 4. So that equation is basically telling us the position of a particle depending on the time. So for example, at t equals 0, S would be 5 lots of 0 minus 3 lots of 0 plus 4. So S would be 4 meters from some fixed origin. Whereas when t is 1, S would be 5 lots of 1, well, 1 squared, which is 1 minus 3 lots of 1, add 4. So that'd be 5 take 3, add 4, which is 6 meters from the origin. And t equals 2, you'd carry on and get that is 20 take away 6, add 4, which is 18 meters from the origin. It might not necessarily be meters, it could just be 18 centimeters or any other unit. That's basically how that equation is used. So as t changes, it tells you the position. They could say, okay, find the velocity of this particle at t equals, let's go 5. So the reason differentiation is useful is it tells us how quickly something is changing. So differentiation tells us the rate of change of a variable. So an example would be when you've done differentiation before, it's to find the gradient. The gradient is how quickly is the y-coordinate changing. Because if it's changing quickly, the gradient's bigger, so it means it's steeper. Because if I had a straight line here, that would be, like, let's say every 2 to the right it goes 5 up. That would be a smaller rate of change than if, for example, it was every 1 to the right, it went 5 up. So we can now use that for variable accelerators. So we can now use that for mechanics to say, well, velocity is how quickly your position is changing. So the velocity, which would mean it's whatever this S equation is differentiated, which is 10t minus 3. So that would be the equation for the velocity if your position equation would be the 5t squared minus 3t plus 4. So at t equals 5, the velocity would be 10 lots of 5 minus 3, which is 47. And it can go further. You could find the acceleration. At t equals 5. So acceleration is how quickly your velocity is changing. So if we differentiate again, v equals, acceleration would equal your velocity differentiated, which would mean it's just 10. So in this question, turns out that it's actually, the acceleration's always 10. So even though on this one, it turns out to be the same, we were able to use differentiation. We would actually just normally use suvat if the acceleration's the same. But it doesn't matter which we use, this is just kind of a better method. But it's better to stick with suvat normally if the acceleration's the same, whereas I'd stick with differentiation and integration if the acceleration's changing. So a summary of the idea here is that if you have your S equation and you want to get to your V equation, you differentiate it. If you have a V equation and you want to get to an A equation, you also differentiate it. And even though we haven't covered it in this today, you'd integrate to go the other way. But I will deal with that in lesson on Monday. So let me do one more example. Example 2. Okay, so S equals 5t cubed minus 10t squared. A. Find the velocity at t equals 4. So if we're doing that, using that SVA rule, we differentiate it. So V would equal 15t squared minus 20t. So at t equals 4, V would be 15 lots of 4 squared minus 20 lots of 4. So that there would be 240 minus 80, which gives us a velocity of 160. They could say something along the lines of find when the particle is at rest. So that would mean when is V equals 0? Because when is the particle stopped? So if we use our V equation, you'd have 15t squared minus 20t. So it turns out, based on this, that it happens when t equals 0, but it also happens when t is 4/3. And finally, find the acceleration at t equals 2. So if we differentiate it again, A would be 15t squared differentiates, gives you 30t. Just go back to red, forgot to change. 30t, 20t differentiated is 20. So at t equals 2, a is 30 lots of 2 minus 20, which is 40. So I would like you to attempt the questions on exercise, let me just check what it was, exercise 11.1 and 11.2. You now have enough information to do that. I will be going through how to do the stuff to do involving integration in the next lesson on Monday, so you will need to have an understanding of this before we get to that. Okay, thanks.